right, we are going to be working on math packet number 10. It is due Thursday, April 21st. Instead of being due on a Tuesday like normal because of Easter, we're making it on a Thursday. So it's due Thursday, April 21st. Shh, this is the last one I'm going to give you, Nolan. Ryan, please pass that to Nolan. So a machine at a local factory has 3 gears. One gear must be replaced every 3 months, another every 5 months, and the third every 6 months. All of the gears were just replaced in September of 2016. In what month and year will all 3 gears need to be replaced at the same time again? What do you think we should do to solve this problem? How can we solve this? Nobody has any thoughts on how to solve the problem? Nolan?
Wait, but all in order, just search.
Will, what do you think?
Don't you just do every 6, you just add 6 months to September?
So we have 3 different gears. One is every 3 months. One is every 5 months, and one is every 6 months. So yeah, if we start in September of 2019, and you're right, I see every 6 months there. So I'm going to say, okay, so there's 1 gear that was replaced in September, and then October, November, December, January. So this is January of 2000. Oh, sorry, that was a 16, not 19. So this is 2017. February, March, April, May, June, July, August, September, October, November, December, January. This is of 2018. Okay, so I'm going to pause there and I'm going to see if I have to go any farther. So what Will said was we'll mark every 6 months. So I'm going to put in X every 6 months. So this would be 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. Okay, so I'm going to pause and see, do I need to go farther? Or do they overlap? What should I do for my next one? I have to go every 3 months. I'm going to do this one in green. So every 3 months, so 1, 2, 3. 1, 2, 3. Then I have to go, what should my last one be? Every 5 months. I'm going to do the same thing, and I'm going to see where they all 3 land on the same month that they need to be replaced. I can see what month it is and what year it is. So you're going to have to show that on your paper. Show the months out. Show how you found where that overlap happened. Our next page, Keith baked muffins and gave 3/4 of them to Peter. Peter then gave away a dozen of the muffins. Peter ended up with 6 muffins. How many muffins did Keith bake? Now this is where I come back to my bar model. Love bar models for solving word problems. So I'm going to start with my bar. I want to know how many muffins did Keith bake? So that is my question. How many muffins altogether did he bake? How can I divide my bar up with the information they gave me? Keith baked muffins and gave 3/4 of them to Peter. So how do you think I want to break my bar up if he gave 3/4 of them away? Into fours, because he gave 3/4 away. So these 3 he gave away. He gave to Peter. So Peter gets 3/4. Peter then gives away a dozen of the muffins. And he ends up with 6 left. So he gives away a dozen. So here's Peter. He gives away a dozen muffins and he has 6 left. So how many muffins did Peter get?
18.
Yeah. So Peter had 18 muffins. How many units does Peter have? How many units did Peter get? 3, because he got 3/4. So we know 3 units equals 18 muffins. How much is 1 unit? Oh, 6. Who said 6? How did you find that?
I divided 18 by 3.
Yeah, there's 18 muffins in 3 units. So we divide those 18 muffins by our 3 units. And so 1 unit equals 6 muffins. So 1 unit up here is 6. How many units do we have all together? Because remember, our question is how many units do we have? How many units do we have all together, Tristan? 4. We need to find out how many 4 units are. What math am I going to do? If I know each unit is 6 and there are 4 units, what math am I going to have to do, Nick?
You could do 6 times 4.
Yeah, I could do 6 times 4, or I could add them all up. So 4 units I know would be 6 muffins times my 4 units. And that would tell me how many muffins he had all together. Do I want to see just an answer put on your paper?
No.
Absolutely not. Show me how you get your answer. Bar models are a wonderful way to do the word problems. You can use that bar model to help break down the information they give you to find what their question mark is. Our next page is that 5-card challenge. Remember, the ace is a 1. You can multiply something by 1. That's adding an operation. You can divide something by 1. It adds an operation. It helps build how many points you can get. Now, find the area of the shaded region. All work must be shown. So first it says the area of your figure. Our figure is that full rectangle. How do we find the area of a figure or of a rectangle? Will? You found the volume. How do you find the area? Just length times width. Length times width. So you know the length and you know the width. Do the math. How I found it. Show me the equation that you're doing. Okay? Show me what your equation is. Length times width. This is my shaded area. You couldn't really see it on my scan there, but that's the shaded area. What shape is that?
It's a triangle.
It's a triangle. We need to find the area of that triangle.
Please pardon this interruption. This is the last call teachers and staff for the coffee truck. If you need your beverage, please go and get it. Last call for the coffee truck. Thank you.
The area of the shaded region is a triangle. How do I find that? Anthony?
Like base times height divided by 2?
Divided by 2. So 1/2 of the base times the height. So base times height divided by 2. So do we know what our base is? Real? 8. That base of the triangle is right here. What is the height of the triangle? Real? 6 inches, because here's our height. Going from the base right up to the top of our triangle. So show me your equation that you're doing with our base and our height. Show me the equation and write the answer. I'm going to give us a challenge because that was pretty easy. I want you to tell me the area, area of the white. It's really not that challenging if we know the area of the figure and the area of the shaded. Take it one step further and tell me the area of the white.
24, right?
Well, I'm not literally asking you to tell me the answer right now. I want you to show me how you found it. If you know the area of the figure and you know the area of the shaded, you should be able to find the area of the white.
The answer of the shaded.
Because we're subtracting the shaded out of the rectangle. You have to take the shaded out of the full area to find what's left. So my challenge to you that I would like everybody to add is to tell me what's the area of the white. Anthony.
Is it? Not asking.
You're not telling me an answer right now. You're writing it on the paper.
Oh.
So write it on the paper. You should be able to find the area of the figure and the area of the shaded, and with those two pieces of information, you can take away the shaded so you're just left with the white. So take away means we're doing what operation? If we're taking away, we're subtracting. So you need to get in that habit of understanding you're subtracting to find what's left. Anthony.
Oh, so is this an extra point?
No.
It's part of the problem, sweetheart.
Oh, it is.
Yes. So write it on your paper. Area of white. You need to find that. The first 5 figures of a pattern are below. Study them and answer the question assigned for your class. So we just have to do the Math 6. For the Math 6, for the 7th figure in the pattern, how many blocks will be in the outermost layer? What color will the layer be? Well, what do we have to do in order to find the 7th layer? You have to fill in at least the first 5 that they give us so we can find what? What are we looking for? How do we find the answer? What is it that we look for? Nick?
You have to look for a pattern.
We have to look for the pattern. In order to find a pattern, you have to start filling in your table. That table is what gives us our pattern. So let's look at what we have. How many yellows are in my first figure? Just say it out loud. How many are in the second?
1.
How many are in the third?
1.
How many are in the fourth?
1.
How many are in the fifth? How many yellows altogether? I think somebody was saying it. Just say it a little louder for me. 33. How many blues are in our first how many pink are in the first pattern? 0. How many are in the second?
8.
How many are in the third?
8.
How many are in the fourth? How many are in the fifth?
48.
How many pinks are there?
What?
8. So this is our first, second, third, fourth, fifth. How many blues are in our first? How many blues in the second? How many blues in the third? How many in the fourth? How many in the fifth? How many reds are in our first? Second? Third? Fourth? Fifth? How many total in the first? Second? Third?
27.
So in our third, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Easy way to do it. Easy way to find your total. 1, 2, 3, 4, 5 for my length. 1, 2, 3, 4, 5 for my width. How many? 5 times 5. 25. How many are in the fourth figure? There's 7 and 7, so it's 49. How many in the fifth figure? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's 9 times 9?
81.
So here we had 7 across and 7 down. Here we had 3 across, 3 down. Here was 1 and 1. Are we seeing a pattern with my total numbers?
Yes.
What kind of numbers are these?
Oh.
Perfect squares.
My calculator.
1 squared, 3 squared, 5 squared, 7 squared, 9 squared.
11 squared.
What's my total for number 6? 11 squared. What would the total for the 7th be?
13.
13 squared. So we can follow that pattern for my total number. Yeah, it's our odd numbers. Our odd numbers we're squaring. So, let's see what else we can fill in just by knowing certain patterns. Do we know how many red are going to be in the 6th figure? Just by looking at it? How do you know it's 24? What pattern do we follow, Brielle?
It's every 4.
Every 4. So we had 4 of 1 yellow. We had 4 of 8 pinks. So we need 4 of the 24. We need 4 of the 16. We need 4 of the 33. Because it doesn't jump up till every 4th. Right? So, can we figure out what our total is for the 6th figure? We know it's 11 squared. What's 11 squared? Anthony?
11 times 11.
Yeah, what is it? 121. Do we know the total for the 7th?
Yes.
Yeah, it would be what? 13 times 13 is what? 169. So if we know these 4 boxes, can we figure out our pink? If you know the total is 121, and we know how many red and how many blue and how many yellow, can you figure out how many pinks there would be? What math would we do? If you know the total amount, and you know 3 of the 4 numbers, how can you find that 4th number?
You add all the numbers you know and then you subtract them
From what?
from 121.
Yeah, we know 33 plus 16 plus 24 is getting us to 121, but we're missing the pink. So if we subtract what we know away from the total, we'll be left with how many are pink. Could we fill in the rest of the table with that knowledge? Yes. Can we do the same thing then to find our blue? if you know the red, yellow, pink, and red, and the total, could you then find the blue? Yeah, you do the same thing.
Yeah, I just do like addition way. I did like what like 8, well, and then like after and then like plus 8, and then plus 16, and then plus 32, and then plus 40. No. It keeps on adding.
So
8.
come show me what you got, and let's see if you got it correct. No, your paper.
Oh,
Your paper. Yep, that's not correct. Because if we were to add these up,
yeah. No, I just fall for you put it on there.
but it's not 32.
Oh, so we have to complete the whole thing or just a total?
You need to answer the questions.
Oh.
How many blocks are going to be in the 7th outermost layer, and what color is it going to be? So I'm telling you right now, you didn't fill in the correct answers.
All right.
So that's going to throw off your answer to these questions. Yes. Yep. So it's going to take a little bit of work, friends. It's not easy peasy lemon squeezy. You have to think it through. Your answer that you're going to put down here is how many in the 7th figure, how many will be in the outermost layer. So you're going to want to know how many are in the outermost layer and what color that outermost layer will be. So you're going to have to do some thinking on that one. I'm not going to give us the full-on answer. I want you to use your brain. I want you to think it through a little bit. All right, now we have our figures. This time we're finding volume. Okay? So you don't have to complete the whole table, no. So we need to find the volume. So I'm going to give you the formulas for the volumes of some of these solids. We've been talking about solids yesterday in math class. So now we want to use some of that knowledge to find our volumes. So for a rectangular prism, it's length times width times height. For our cube, it is the side cubed. Remember, that is the same number for the length as for the width, as for the height. Multiply that number 3 times. So remember the last time it was 27. 3 times 3 times 3 got us 27. Find what number, when you multiply it by itself 3 times, gets us 1,331. Our triangular prism is 1/2 length times width times height. So it's like the rectangular prism, but because it's triangular, we have to divide it by 2. Our pyramid is 1/3 length times width times height. Our cylinder, pi r squared times the height. So it's that area of the circle times the height. So we know area of circle is pi r squared. Now we multiply it by height. Our cone takes that pi r squared times height. But because it's a cone, we have to divide it by 3. And our sphere is 4/3 times pi r cubed. For Math 6, you need to complete 2 of them. My challenge to you is to try to do more than just 2. Okay? Try to do more. See, this is going to prepare us for that math test coming up in a few weeks. So we want to work with these formulas. Try to get comfortable with working these formulas, finding the numbers that could fit into them. See how many of these formulas you can do. You have to do 2 of them to get full credit for the page. See how many more you can do. Okay? See how many more. That is it for this packet. So if you are watching this again at home, I hope you are well, and I hope to see you soon.